Hello, my name is Lassi Meronen, and I'm presenting our paper titled Stationary Activations for Uncertainty Calibration in Deep Learning. This is joint work with Christabella, Irwanto and Arno Solin at Aalto University in Finland. Neural networks often have high predictive accuracy but poor uncertainty estimates. On the other hand, Gaussian process models allow encoding prior knowledge through the covariance function and provide good uncertainty calibration. We aim to provide tools for transferring some of these appealing properties from Gaussian processes into neural networks. The link from the activation function of a single-layer infinite-width random neural network to the corresponding GP kernel is generally well understood. But here we consider the opposite problem and solve the activation functions corresponding to the Mattern class GP kernels. We do this by writing the covariance function in terms of its spectral density function and reduce the problem to analyzing transfer functions. By doing this, we derive the Mattern activation functions as described by this formula here. And on the top left, we have plotted these activation functions with different smoothness parameter values. And on the top right, we can see that by Monte Carlo integrating these activation functions, we recover the original kernels extremely well. And here a simple 1D regression example shows that using these activation functions, we can encode similar prior knowledge into neural networks as we can into GP models using the corresponding kernels. And on benchmark classification tasks, Mattern activation functions outperform approximate neural network GP hybrid models in terms of negative log predictive density and other metrics. And here an out-of-distribution experiment on image classification with CIFAR-10 shows that using the Mattern activation functions, we get good separation between known class and unknown class samples, whereas with the ReLU activation, we get hardly any separation at all. Also, misclassified example images below are much more sensible with the Mattern activation functions. And then a short recap. We introduced a new family of nonlinear neural network activation functions that mimic the properties of the Mattern family of kernels in GP models. Mattern activation functions result in both good performance and uncertainty calibration in Bayesian deep learning tasks, and results are particularly good on out-of-distribution uncertainty estimation. Thank you for listening, and feel free to contact me if you have any questions.